Hello, myself Dr. Umaira. I am from JT Arts Science and Commerce College, Malegaon. My topic is colorimetry and spectroscopy. Colorimeter and spectrophotometer are the instruments used to determine the concentration of biochemical compounds. These methods of analysis are called colorimetric methods or C methods. This method consists of its principle, its working, and its application. The colorimeter and spectrophotometer work under the principle of Beer-Lambert's law. According to this law, when a ray of monochromatic light passes through an absorbing medium, its intensity decreases exponentially as the length and concentration of absorbing medium increases. Colorimeter determines the absorbance and thereby concentration of biochemical compound in the visible region from 400 to 800 nanometer of electromagnetic radiations. However, spectrophotometer is of two types: ultraviolet spectrophotometer and visible spectrophotometer. Ultraviolet spectrophotometer determines absorbance in the ultraviolet region of electromagnetic radiation, while visible spectrophotometer determines absorbance in visible region. So this is the principle of these two instruments. They work as the main component of colorimeter and spectrophotometer are a source of radiation recorded in visible spectrophotometer and colorimeter. Light source is usually a tungsten lamp, while in ultraviolet spectrophotometer light source is either hydrogen or deuterium lamp. The radiations from the lamp passes through a slit to a condenser lens. The lens allows parallel beam. The beam falls on the test solution kept in a quid. Beyond the quid, a filter is placed. The filter allows maximum transmission of the color absorbed. The filter is selected according to the color of the solution. If a blue color is under examination, then red is absorbed and red filter is selected. The color of the filter should be therefore complementary to the color of the solution under investigation. The filter is chosen so that Beer's law is obeyed. The filter gives narrow transmission and approximate to monochromatic light. The light then falls on a photocell. It generates an electric current in direct proportion to the intensity of light falling on it. This small electrical signal is increased in strength by the amplifier. It is then transmitted to a galvanometer or digital recorder. Both types of instruments contain a wire with plug pin, an on-off switch, a quid holder, and a zero set knob. The wire is connected to the main power line. The switch is kept on. A blank solution is poured into a quid and the quid is placed in the quid holder. The zero set knob is adjusted to bring the galvanometer to zero. The quote is then replaced by the test solution and reading is observed. The reading in the meter is the optical density of the solution. The colorimeter and photospectrometer is used widely to assay wide range of biological important molecules like amino acids, proteins, carbohydrates, nucleic acids, steroids, hormones, etc. The ultraviolet and visible spectrophotometer provide the most commonly used assays of enzymes and their substrates. They are also used for the estimation of large number of inorganic and organic substances. In such a way, the spectrometer of a single beam photometric colorimeter is widely used for the estimation of enzymes, proteins, amino acids, carbohydrates, nucleic acids, hormones, organic and inorganic substances, and they are very much helpful to estimation of such components in a very safe and easy way.